In this breakdown, we're examining what happened with Intuitive Machines' second lunar lander mission, IM-2. NASA funded this mission under the Commercial Lunar Payload Services program, entrusting Intuitive Machines with everything except the payloads: launch, operations, communications, and landing. Unfortunately, issues arose during the landing phase that resulted in the mission ending much earlier than anticipated. So, what went wrong? The short version: the Nova-C lander took a tumble, ending up on its side in a crater. NASA's Lunar Reconnaissance Orbiter, circling the Moon, later spotted it and confirmed the rough landing. The lander hit the surface faster than expected and skidded into a 20-meter wide crater, tipping over about 250 meters from its target, well outside the intended 50-meter landing ellipse. This touchdown in the Mons Mouton region, just 5 degrees from the lunar South Pole, marked the southernmost landing ever on the Moon. Landing near the South Pole is no easy feat. Unlike the Moon's mid-latitudes, where you get stark contrasts of bright white and deep black, this region is a muted grey. The sun sits low on the horizon, casting long shadows from crater rims, slopes and boulders, making navigation even more difficult than normal. For IM-2, those tricky conditions spelled trouble. Due to the Nova-C lander ending up on its side in a crater, it wasn't able to receive enough power to complete its mission objectives. Still, with battery power and the meagre amount of solar power received, it wasn't a complete bust. A high-quality image was received showing the landing site and the orientation of the lander. With remaining battery power available, it was able to operate the Prime 1 drilling payload. In the press conference just held after the landing, NASA confirmed 2 payloads were active on the lunar surface. Nikki Fox, the Associate Administrator of Science Mission Directorate, said that the M-Solar payload was also active. That is a mass spectrometer that can measure drilled samples from the Prime 1 drill. An update from Lunar Outpost, that had a mini rover on board, stated they had received data from their rover during transit and on the surface of the Moon. Unfortunately, the garage housing the rover was wedged upside down under the lander, preventing the deployment of the rover to the lunar surface. Because of the extreme cold temperatures in the crater, and the direction of the sun, and the orientation of the solar panels, the battery couldn't recharge. The mission was declared over, and teams are assessing the data collected from the lander and the payloads. Although it's unfortunate the mission ended so soon, it's worth noting that the South Pole is a difficult landing location, and that lessons will be learned and applied in future missions. Payloads. The IM-2 mission packed some bold and innovative payloads, each designed to push the boundaries of lunar exploration. One standout was a micro-hopper strapped to the side of the Nova-C lander. The plan? It would blast off, land inside a nearby crater, snap images and video, then hop back out to relay its findings to the lander. Another key payload was Prime 1, an ice drill mounted on the lander's exterior. This tool was built to bore up to 1 meter, that's 3 feet, into the lunar surface, extract samples, and pair with a mass spectrometer to analyze them. The goal was to unlock clues about lunar ice and volatiles, critical resources for future missions. Despite the lander tipping over, NASA reported that Prime 1 was still able to move, demonstrating a full range of motion. The mass spectrometer also picked up traces of gases, likely kicked up from the lander's engines during its rough touchdown. Then there was a Nokia 4G network in a box, a compact system loaded onto a mini rover. Its mission? Test 4G communications on the Moon. This tech is a big deal for NASA's upcoming Artemis program, which aims to connect astronauts on the surface. The Axiom spacesuits they'll wear are set to feature embedded 4G transmitters and receivers, making reliable lunar networks a reality. Sadly, with the rover trapped under the upside-down lander, this experiment could not be performed. Even with the lander toppling over in a crater, these payloads still delivered partial successes, proving their potential for the road ahead. Location. The intended landing site for Intuitive Machines' IM-2 mission was roughly 160 kilometers from the lunar South Pole and 175 kilometers from the IM-1 landing site. This spot sits in the central part of one of the potential landing regions eyed for NASA's Artemis 3 mission, In reality, IM-2 missed its mark by about 250 meters. The exact reason for the off-target landing isn't clear. It's possible the hazard avoidance system kicked in, steering the lander away from the planned site to dodge perceived risks. But landing in a crater suggests something went wrong. Perhaps glitches in the navigation, guidance, or even the lander's sensors played a role in the lunar detour. Noisy laser altimeters. Intuitive mentioned in the press conference about noisy laser altimeters. Their first indication of problems with the IM-2 mission, which had been flawless to this point, was when the lander changed from a low lunar orbit of 100 kilometers into a highly elliptical 100 by 10 kilometer orbit around the moon. Firing the laser altimeter at this low altitude resulted in noisy measurements. The team thought that as the lander descended to the surface, the signal would grow stronger and the signal-to-noise ratio would increase. That didn't happen. The laser altimeters were noisy all the way down to the surface. What are the possible reasons for a noisy laser altimeter? It could be the laser altimeter was not calibrated for the extreme lunar environment, leading to beam divergence that reduced the signal-to-noise ratio and caused the return signal to be scattered or faint. Or it could be that vibration and thermal issues had caused a misalignment between the laser emitter and receiver. Another possible factor could be lunar surface reflectivity. The landing location close to the south pole of the moon is scattered with craters, highland and shadowed regions. The reflectivity of the surface varies considerably. Darker, uneven surfaces or dust could scatter the laser beam, introducing noise. The low solar incidence angle could exacerbate this by casting long shadows, reducing consistent reflection back to the sensor. A third possible factor could be lunar dust. Loose dust could be disturbed by the exhaust fumes as the lander descends to the surface. In the vacuum of space, the dust can linger longer than on Earth, potentially crossing the laser path and causing reflections or reduced signal strength. Whatever the reason, problems with the laser altimeters is a critical issue that needs to be addressed before the next mission to the moon. Is the tall and slim design a problem? This question was asked at the press conference after the landing. The CEO of Intuitive Machines, Steve Altemus, gave a clear and definitive answer: no. He said the center of gravity of the lander is low. Heavy payloads are low on the spacecraft, so are the helium tanks, and of course the large engine is at the bottom of the lander. It's worth noting that the fuel tanks would be mostly depleted when coming in to land. They had fired for over 23 minutes since takeoff, with a full continuous 15-minute firing during lunar descent. He said center of gravity is a basic physics issue, well known and understood, and that it wasn't a cause of the tipping over. The first mission, IM-1, tipped over because the lander had too much vertical speed when landing, resulting in one landing leg snapping, causing the vehicle to tip over. Given the lander came down inside a crater, it likely landed at an angle and could have tipped over. We're just not sure yet. Upcoming events. Intuitive Machines has secured contracts by NASA for 2 more missions named IM-3 and IM-4. At the IM-2 press conference, CEO Steve Altemus addressed whether the mission's challenges, such as a noisy laser altimeter issues, might delay IM-3, currently scheduled for launch in about a year. He said yes, but not for the reasons you might think. Intuitive Machines has a contract with NASA to provide services for their Near Space Network, a system that includes lunar data relay satellites. One of these satellites will hitch a ride to the moon alongside the IM-3 lander as part of a rideshare mission. Since both the lander and the satellite are lunar bound, IM-3's launch hinges on the satellite's completion, potentially pushing the timeline back if it's not ready in time. Looking ahead, there's reason to be optimistic about Intuitive Machines' next lunar attempt. They've already landed on the moon twice, a remarkable feat, even if the IM-2 lander tipped over post-landing. It's worth noting that even if the lander tipped over afterwards, they are 90% of the way to mastering landing on the moon. Do you think Intuitive Machines will be able to successfully land on the moon with their next mission? Or do you think they haven't shown they are capable of learning lessons from previous missions? Let me know in the comments section. Thanks for watching. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.